If your AI doesn't create measurable margin, it's not a project, it's a cost center. If you're looking for prompt hacks or shortcuts, this channel is not for you. Here, we design AI systems that must survive production, withstand audit, and create measurable value. Welcome to Context Engineering Mastery. In our inaugural episode, we established that tokens and latency are business constraints. Today, we move from the what to the economics of execution. The core mistake made by 90% of enterprises is uniform model usage. They treat every query, from a simple summary to a complex financial forecast, the same. At low volume, this looks acceptable. At scale, this inefficiency destroys your unit economics. This is the $100,000 prompt trap. This is not a technical problem. It is an allocation problem. We will examine 3 routing strategies used to control LLM cost at scale. We call this the RACE framework applied to cost: research, analysis, comparison, and execution. Strategy number 1. The cost performance router. The first layer of defense is hierarchical routing. We apply the Goldilocks principle, finding the model that is just right, not too slow, not too expensive. We implement a cost performance router. Crucially, the router doesn't just look at difficulty, it looks at legality. A query containing PII or sensitive client data must be routed to a secured, private model regardless of the cost. Compliance is not an optimization variable. It is a binary prerequisite. If the query is low risk, level 1, the request is routed to a lower cost model. If it requires deep analysis, level 3, it is routed to the flagship model. This simple logic cuts inference costs by 50% without sacrificing quality for critical tasks. Strategy number 2. The context compression pipeline. The second lever is context density. Your RAG pipeline must be a compression pipeline. We feed large documents to a fast, cheap model first, instructing it to generate a highly condensed, abstractive summary. We then feed only that summary to the expensive model. Technical teams often argue this adds latency. The counter-argument? We trade 400 milliseconds of latency for 40% gross margin. Speed is a commodity. Profitability is a necessity. Strategy number 3. The output caching layer. The final lever defeats the time to first token, TTFT, cost. If the system receives a recurrent query, it should never pay for the calculation twice. We implement a semantic cache layer. When a user submits a query, we first check the cache. If a match is found, the response is returned instantly. Latency is near 0, and cost is 0. However, optimization introduces risk. A loose semantic cache can serve stale or inaccurate data. A router configured solely for cost can send complex legal queries to an incompetent model. A system that is cheap but wrong is not optimized. It is broken. The goal is not just saving money, it is predictability. How do you know if caching is working? You track the cache hit rate. If you are below 10%, your cache is pointless. Your profitability target is to raise that number to 30% for recurrent queries. That is the only metric that matters. 3 takeaways for your architecture. 1. Route by compliance first, complexity second. 2. Compress context before you pay for it. 3. Never compute the same answer twice. Now that we have optimized the cost, the next question is obvious. How far can we push this system before it becomes fragile? Today wasn't about saving tokens. It was about deciding which computations deserve your money. In the next episode, we'll address the harder problem. What happens when this optimized system becomes unpredictable at scale? If this was useful, it was not by accident. I'll see you in the next episode.